Hello everyone. In this session, we are going to discuss about analysis of discrete time system using Z transform. Any discrete time system can be described with the help of difference equation. From the difference equation, we can able to find out system function, impulse response. From the system function, we can able to analyze whether the system is stable or not, whether the system is causal or not. System function is the ratio of Z transform of output of the system by input of the system. Z transform of impulse response will yield you system function. Similarly, inverse Z transform of system function will give you impulse response. If the system is described with the help of difference equations means first of all we need to find out the Z transform of the given difference equation. From that, we need to obtain the expression of h of z, which is nothing but y of z by x of z. Then that can be analyzed for the stability as well as the causality of the system function. Now we will see the one example problem for the system analysis using Z transform. Impulse response is nothing but response of the system when the input for the system is unit impulse signal. The example problem is a DSP system is described with the help of difference equation y of n equal to zero point 0.2 y of n minus 1 plus x of n. Find the impulse response h of n. To find the impulse response of the system, first we need to find out system function. Then just by taking the inverse Z transform of system function, we will get impulse response. So for the given difference equation, first you take the Z transform. When we take the Z transform, what we will get is y of z equal to zero point 0.2 Z inverse y of z plus x of z. Then you segregate y of z terms at the left hand side and x of z term at the right hand side. Then you find out the ratio of y of z by x of z, which is nothing but system function h of z. That what we will get is z by z minus zero point 0.2. Then take inverse z transform for the obtained system function. The final result is zero point 0.2 power n into u of n. The next example problem is a relaxed system with zero initial conditions is described with the help of difference equation y of n plus zero point 0.1 y of n minus 1 plus minus zero point 0.2 y of n minus 2 is equal to x of n plus x of n minus 1. A. Determine a system response due to impulse input sequence. B. Determine the system response due to unit step input sequence. First, we need to find out impulse response, then we have to find out step response. As I said earlier, the impulse response is nothing but the response of the system when unit impulse signal is applied at the input side. So x of n equal to del of n. When you find out the x of z, what we'll get is 1 because z transform of unit impulse signal is 1. Now we have to take the z transform for the given difference equation. Then what we will get is y of z plus zero point 0.1 y of z z power minus 1 minus zero point 0.2 y of z power minus 2 equal to x of z plus x of z into z power minus 1. Then we find out the ratio of y of z by x of z. The ratio of y of z by x of z is 1 plus z inverse by 1 plus zero point 0.1 z inverse minus zero point 0.2 z power minus 2 because here x of z equal to 1. In the y of z expression, we just take the in the numerator part, we just take the z as the common function. Then what we will get is z into z plus 1 by z square plus zero point 0.1 z minus zero point 0.2. Now you factorize the denominator. Then we will get two factors. One is z minus zero point 0.4 into z plus zero point 0.5. Then apply partial fraction. What we'll get is y of z by z equal to a by z minus zero point 0.4 plus b by z plus zero point 0.5. Find out a and b values. We will obtain a value as 1.556 and b value as minus 0.556. Then substitute the a and b values in the y of z expression. Then take inverse z transform. Now we will get y of z equal to 1.556 z by z minus zero point 0.4 plus minus 0.556 by z plus zero point 0.5. When we take the inverse z transform, we will get if y of z equal to, that means impulse response as 1.55 into 0.4 power n into u of n minus 0.556 into minus zero point 0.5 power n u of n. Now we need to find out step response. Step response is nothing but output of the system when input is unit step signal. So x of n will be considered as u of n. When we take Z transform for u of n, the result will be x of z equal to z by z minus 1. So now y of z can be written as x of z into h of z. So z by z minus 1 into 1 plus z inverse by 1 plus zero point 0.1 z inverse minus zero point 0.2 z power minus 2. Now you multiply numerator and denominator, then apply partial fraction, then find out a, b, c values. Now a value will be obtained as 2.222 and b value will be obtained as minus 1.037 and c value is obtained as 0.1852. After obtaining the ABC values, substitute in the y of z expression, then find out the inverse z transform for the y of z, then we will get the step response. The finally obtained step response expression y of n equal to 2.222 into u of n minus 1.037.4 power n u of n minus 0.1852 minus zero point 0.5 power n u of n.